Today, in the interests of annoying phone users and computer users equally, we shall be filming in square format. But not quite, just to annoy the mathematicians. Some idiot going by the name of Bev has asserted that using a thing to define a line between 2 points means that those 2 points can't possibly be on a curve. This is idiotic because 2 points can be on pretty much an infinite number of curves. In particular, he insists they couldn't be on a circle. Here we have 2 points, A and B, on a circle linked by a straight line. So that's you debunked, isn't it? Idiot. Was that too fast, too easy? Let's add another line. From the centre down the bottom right, through the centre point of that purple line, and off out into space. Oh, I said space, they're not going to like that. Through the centre point of the purple line C, where it intersects at a right angle, which for a spherical and non-rotating mass would make it horizontal, perpendicular to the radial. It's a little more complicated if you have uneven distribution of mass and the thing's rotating and so on, but there you go. That purple line is horizontal at its centre. Is that still too simple? Too straightforward? Was it already too complicated for flat earth idiots to understand? Was it both? That's fine. We can label 2 more points. O, the centre of the circle in the bottom right there, and D, the centre of the arc from A to B. Notice the red line goes from O through C and D and beyond. So what? So we've got a bunch of points. Big deal. Based on those points, we can add more lines, creating triangles. AOB is a triangle linking the 2 ends of our arc, and indeed straight line, and the centre of the circle. ADB is a triangle linking the 2 ends and centre of the arc. Note, C is not a vertex of either of these triangles, but it is on the midpoint of one side of each of these triangles. Great, triangles. What can you do with them? All kinds of things. You can find the incenter, the circumcenter, the orthocenter, the centre of gravity. I think I just upset them again by mentioning gravity. You can also copy those triangles and rotate them 180 degrees, which puts them off the diagram. 2 copies of triangle ADB, one moved to the top right, one moved to the bottom left, gives us that extra purple line, also perpendicular to the red line, but going through D, not through C. 2 copies of the yellow triangle AOB, rotated, again, up, right and down left, again, going off the diagram, give us another purple line which you probably can't see in the bottom right because the frame rate counter is right on top of it. And if I mess around changing the size of this, the recording is going to break. So I'm not going to change the size of the recording. I'm going to zoom in just a little and scroll down. And you can see there is a little purple line in the bottom right. We now have 3 purple lines, which are, by geometric construction, all parallel to this middle one going through C, and therefore all perpendicular to the red line. At point D on the surface, those are all horizontal lines. They're just at different altitudes, or depths, depending on our point of view. Now, having constructed this, you can see that the farther from D A and B get, the closer to O, and the farther from D, C will get to a point. And you could measure that. You could measure OC on an accurately drawn diagram. You could measure CD if you want to. But obviously CD is OD minus OC, so you can calculate it rather than measuring it if you prefer. If you're interested in CD, you can measure it directly or calculate it. And you can measure the curved line, not this straight pale blue line, the surface of the green, dB or dA, whichever side you prefer. Whichever way you like to swing. Just upset some more people, didn't I? And you could plot a graph. Oh yeah, you could plot a graph of OC, the distance from the centre to the midpoint of that straight line, divided against dB divided by OD. In other words, how far around you are as a proportion of the radius, meaning the angle in radians. We have a quarter circle where it will be 0, a half circle where it will be -1, a three-quarter circle where it will be back to 0 coming up the other side, and a full circle all the way back around to where you started. You are back at D, of course it's 1. This is known as the cosine of the angle. Bit of a hint, graph equals cos x, it's nothing to do with lettuce. Of course, as drawn, that was a very huge one. Here we have something to scale. And yes, that green bit is actually part of a circle. Just going to have to zoom right in, and across here you can see, maybe, just about, if I zoom far enough in, you can see this fade in this row of pixels, and then in the next row of pixels. Yeah, and then there you have the center, and there you have that top row of pixels fading out, and yeah, that's actually as much as you get to see on this scale. But from there to there is 5 pixels, including the white lines, which on the scale I have drawn this with a 6,371 kilometer radius would be 500 meters. That's how much of the circle, the circumference 500 meters is, because Earth is pretty big, at least compared to things like 500 meters. And if you do the maths, you can see I have the search result version of the calculation at the bottom. You find that the distance, the sagitta, or sagitta if you want to pronounce it as an English word, meaning the distance CD in that diagram, is 0.0049 meters, also known as 5 millimeters, or just shy of 5 millimeters. Which is, you know, it's there, it exists, it's a P, it's a 2.0 caliber airgun pellet, or BB. That size, that's how far apart those two lines would be, over 500 meters. Of course, 500 meters is a bloody big construction project. If we're talking about using a water level to establish a horizontal line at the center of the straight line from one water surface to the other, you're not going to do that over 500 meters. Generally, you're not. You could if you got 500 meters of hose, but it seems unlikely. Construction on this scale could be a multi-part shopping centre, but then you do each part separately. Or it could be a runway, but take a look at Leeds Bradford Airport, Hanoi International, RAF Linton on Ouse. Take a look at Courchevel Altiport, that's definitely not a level runway. Nobody's going to bother to 5 millimeters. Really, this is an exceptionally large construction project that people just don't do as a single water level. More realistically, you might do a 200 meter project, in which case you get just 785 microns, not even 1 millimeter. It's more than 3/4, but less than 4/5 of a millimeter. Right? And for a normal duty floor, the maximum sand grain size is 4 millimeters, so more than 5 times that. So yeah. If you're doing a domestic project like a 50 meter mansion, It's all of 49 microns, and if your grain size is 49 microns, it's not sand at all, it's actually silt. And you don't use silt and cement powder to make the concrete for a house floor, mansion floor. You use sand. So your grain size is going to be more than 50 microns, otherwise it wouldn't be sand. Which means the amount of earth curvature, the SATA, the drop if you want to call it that, over that 50-metre mansion building project that nobody would trust to a flat earth idiot like Bev, is less than the size of the single grain of sand that's used in pouring the concrete floor. So it can't possibly be enough to matter on that scale, can it? You idiot.